Hi and welcome, I'm Lauro Miller and I make videos about programming. Today we'll talk about classes in JavaScript. Some people hate it, some people love it. I particularly like them because I think it makes the code easier to work with. In any case, you will inevitably come across classes when working in JavaScript, so we definitely need to get a good understanding of them. So let's check the agenda for today and let's start working. Here's what we're going to cover in this part of the series. We'll start by introducing classes. We'll then discuss the class syntax in JavaScript. We'll talk about static properties and methods. We will briefly discuss private fields because, well, in JavaScript there is not really the concept of a private field, but still it's important that we know that it exists, because once we introduce TypeScript into our applications, then this is going to be possible. And we finish by talking about subclasses. Before we jump into the code, I just want to go once again through the diagram that I showed you in the previous part. Here is a more refined version with a couple of constructs that are specific from classes, and let's try to clarify some of the terms here. So first and foremost, you see we have a person class or a person object. Here, the class is really a blueprint for the object. It defines the properties and the methods that an object is going to have, and an object of type person, right? The same thing for the student and for the inhabitant. So here you can see that there is a superclass keyword and a subclass keyword, and this really just means that the person class is the class from which the student class is inheriting properties and methods. So once the student inherits from the person becomes the superclass and the student becomes the subclass. Here, because the inhabitant also has this inheritance relationship to the person class, then the inhabitant is also a subclass. Now you may be wondering what is with these pluses and minuses here next to the properties and methods, and this really defines when a field is private, meaning it can be only accessed from within the class, and when the field is public, meaning it can be accessed by any other classes or any other functions that are going to refer to that object. There is another modifier, which is the protected modifier, and this, I think we normally use this hash here to represent it, but I'm not going to go into details of what each of these mean. Actually, we will discuss this in more details when we talk about TypeScript and about how it really adds a lot of constructs and a lot of possibilities to classes in JavaScript. One final thing I want to mention, if you noticed here at the bottom, I have this interesting address here. And the address with the uppercase A is actually representing a type of an object, right? So the address here is a custom type, which has some properties and some methods itself. And here it is simply indicating that this address here is going to be of a certain type, is going to have a certain shape. When we are using TypeScript, we will see that we can create a type or an interface that is going to be called address, and then we will simply say that this property of the inhabitant is going to be of type address. Now, all the concepts that I'm discussing here, they are valid and widely used in languages that support classes natively like Java and C#, but they are limited in JavaScript. So JavaScript has some of these concepts, for example, inheritance, but it does not have others like private fields. In any case, I think it's important for you to be familiar with them. You don't need to become an expert, but at least you need to know what they mean once you come across these concepts, these constructs somewhere else. Now, there is one thing I want to discuss here with you, and it is that JavaScript allows for only a single inheritance, right? So one object or one class can inherit only from one other class. It can extend only on one other class. Now, this inheritance here, we very often also say class student extends the class person, right? So because the class students adds some additional properties and methods to this class person, then, I mean, actually it doesn't add to the class person, but it takes the methods and the properties from the class person and adds a few other properties and methods. So we say that the student class extends the person class. Now in JavaScript, one class can only extend one other class. So this is invalid. For example, the student cannot extend two classes at the same time. It cannot extend the inhabitant class and the person class. So we have to think of another way, and one possible solution is actually to have the person class as the superclass, and then we have the inhabitant class, and you see here I put two rectangles, and this one here behind it represents that the inhabitant is a subclass of person, but the superclass rectangle represents also that the inhabitant is the superclass for the student class. So as you can see here, it's kind of a chain, right? Quote unquote, a chain. And the person is the superclass, and then inhabitant is extending person, and then the student is extending the inhabitant. Well, now that's really a super basic example. Of course, I don't talk about many other topics related to classes, but at least this is enough for us to understand how to work with classes in JavaScript. So now that we have a basic understanding of what classes are, let's move on to discussing the class syntax. I'm gonna create a new file here, and I'm gonna call this syntax.js. So to create a class, we start by using the class keyword, and then we define the name of that class. Now, it doesn't need to be an uppercase, or it doesn't need to be a name that starts in an uppercase letter, but by convention, we agree that classes are or start with an uppercase letter, and then instances of those classes are going to be lowercase. So here inside this class, I can create a special function called a constructor function, which is going to be invoked every time I create a new object of this class, a new instance of this class. So if here at the bottom I were to create a new person, and notice how I'm using the lowercase p here, I'm gonna create a new instance of the person class by calling new person, like so. Now, once I call this, any arguments that I pass to this function, to this constructor function, they are going to be passed to this constructor here. So if I were to say, for example, name and age, then I can do something with name and age here. For now, let's simply console.log. So I'm going to console.log the name, and I'm going to console.log the age, like so. Now, if I save this, and I'm going to create three persons here, person 1, person 2, and person 3, person 2 and person 3, and then for person 1 I'm not going to pass anything, for person 2 I'm going to pass the name, and for person 3 I'm going to pass both. So Jane, and let's say Jane is 25 years old. I'm going to save this here at the terminal. I'm going to run node syntax.js. And you will see that we will have undefined and undefined. That's as expected for person 1, because both the name and the age are undefined. We have for person 2 printing the name John, but then age is undefined. And then for person 3, we print both of them. What is more common for us to do is to either store the information that we receive from the constructor function, or pass it to a superclass. Because here we don't, or since here we don't have a superclass, let's simply store this information. This.name is going to be equal to name, and here I am creating a new property to this class function. So I'm saying that this class is going to have a certain property called name, and then I'm going to say this.age is going to be equal to age, like so. Now we can also define a method. Let's say hi, for example. This could be a method, and we are going to simply console.log. We're going to console.log hi, right? Hi, I'm, and then here we're going to print this.name, and I am this.age years old, like so. Right, once I save this and now I run it again in the console, then, oops, sorry, of course I need to actually call the methods here. So person1.sayHi, and then we're going to have person2.sayHi, and we'll have person3.sayHi. Once I run this, then you will see that for the ones that received the undefined is here. And for the ones that actually received the value is here. Now, of course, I can change the values of the properties of a certain object. So if I say person1.name is equal to, for example, max, and person1.age is equal to 30, and then I call person1.sayHi, this is going to print the updated values. Once I run this here, you see, hi, I'm Max, and I am 30 years old. So as you can see, once we create the object based on the class, then working with it is really similar to how we would work with vanilla objects in JavaScript. Awesome. Now that we know the basic syntax of classes in JavaScript, let's talk about static properties and methods. So here I'm going to create a new file and I'm going to call this static.js. Now, static properties and static methods, they simply mean that a certain property or a certain method does not belong to the instance, it belongs to the class itself. So let's think about, for example, class calculator. And this class calculator is going to have a couple of static methods. It's going to have a static add, which is going to receive 2 parameters, and it's going to console.log, or it's going to return a plus b. And here it will also have another static method, which is the method subtract, and the method subtract also receives a and b, and it returns a minus b, like so. So if we go back to the syntax file, you will see that here we called the method sayHi on the instance of the class. Here we created a new class, a new person, and then from person1 we actually called the sayHi method. In a static world, we don't call the methods or the properties from an instance. So if I were to do something like this, for example, my calculator is equal to a new calculator, then and simply try to run my calculator.add, for example, with 1 and 2. I save this. Let's come back here to the console and we execute node static. Let me clear everything. It's a little bit better. And then we say node static.js. We will get an error because my calculator.add is not a function. This means that the static methods and static properties, they are not passed to the instances of a class. The correct way of calling this is to actually call calculator.add with 1 and 2. And here we can actually console.log this result to make sure that everything is working as expected. And once we run it again, then we get the result. Just one more comment before we move on to the next topic. When I am using a static method, I can only reference static properties from within this method if I use the this keyword. So let's say that I have, for example, a constructor here, and this is fine if I say, for example, this dot name is equal to name, or let's say, I mean, here I'm a calculator, so let's say mode, right? And we'll say this dot mode is equal to mode. So this could be scientific or some simple calculator mode or something, if you can think of it. And here, however, if I were to try to access the this.mode from within my static method, I will not be able to do so. So let's simply try to console.log this.mode. I'm going to save this, and back here at the console, let's try to run this again. You will see that we get undefined. And this seems a little bit weird, of course, because, well, we should be instantiating, we should have a this.mode here, but as it happens, the mode that we are accessing from within a static method is only accessible or is only looking at static properties of the calculator class itself. If I were to come here at the top and say static mode is equal to scientific, for example, scientific, and then here I'm going to remove this from the constructor and I'm going to save this and run it again, then you will see that it's going to correctly output scientific. So just keep that in mind, that when you are using the this keyword from within static methods, you should be able to access only static properties. In the same way, if you were to come here and say my calculator is equal to new calculator, you will not be able to access static properties from my calculator. So you cannot say my calculator.mode. This doesn't work. If I were to come here and try to execute it, then you will see it's going to print undefined. And that's because, once again, static properties are also not passed to instances of the class. They belong to the class itself. Static properties and methods check. And now let's briefly talk about private fields. So here, let me just do a little bit of cleanup, remove this and create a new file. And it's going to be called private.js. And when I say briefly, I really mean briefly because, well, JavaScript has no classes under the hood, which means it has no private fields. When we introduce TypeScript into our programs, then we have the accessibility modifiers, and we can mark fields as private, as protected, and as public as we want. But in vanilla JavaScript, this is not possible. Now there is a convention that we can follow, and it is to add an underscore to the beginning of the variable name. And this is a quite widespread convention, which means that other developers should also be aware, okay, I should treat this field as a private field, even though it's not really a private field. So here is just one example. Despite setting the this.underscore name despite adding the underscore, I can still come here and say const person1 is equal to new person, John, 25. And if I try to console.log person1 dot underscore name, then I will still be able to print this. If I save here and I come and run node private.js, then it will print John normally. So as you can see, we cannot really have private fields. Yes, it's possible to emulate it. I think it involves using weak maps, but weak maps are not in the scope of this introduction series, so I'm not gonna go into that part of JavaScript. If you're curious, you can definitely do some research, but when we talk about TypeScript, then it becomes really easy to add private fields, protected fields, public fields, and other very cool features to classes. That's it for private fields. Let's now move on to the last topic of this part, subclasses. Here, let's create a new file, subclasses.js. And we try to emulate this behavior, right? So we try to emulate the student subclass, not emulate, but actually implement the student subclass extending the person superclass. So I'm not going to use directly this properties and methods here. Let's think about some simpler cases. So we'll have a class of person, and this person is just going to have a constructor function, which is going to receive a name. And here we will say this.name is equal to name. And then we have a method which is called, let's say hi. And the say hi method is going to return hello, I am, and then we will interpolate the this.name from the person. Now we have another class, which is the student class. And the student class, well, what we wanted to do is to actually extend the person class. For that, we use this keyword extends, and then we pass the desired class that we want to be the superclass of student. Now here in the student, I can also have a constructor, of course. And as you can see, my IDE, maybe yours will also do so, it directly calls the super method. And this super method, what it does is actually it calls the constructor of the superclass. Right, so if I were to, for example, here in the constructor of the student to receive also a name and let's say a university, and here within this the super method, I pass the name as a parameter or the name as an argument, then this name here is going to be the parameter that is going, or it's the argument that is passed to this constructor function, which means that if I were to access, let's do it like so, const my student is equal to new student, and I'm going to pass a name here, John, and then a university, well, that could be again Harvard. Once I save this, or actually once I try to access the my student.name and I console.log this information, like so, then I will be able to do so, even though I am not explicitly assigning this.name equals name in the student class. This feature here, or this operation, is executed in the superclass. Let's save this, and back here I'm gonna just clear the whole thing and run node subclasses.js. Here you can see that it prints the name correctly. I can also call the say hi method from within my student object. If I were to simply say here console.log my student.say hi, this will correctly output hello, I am John. So as you can see, both the properties and the methods of the superclass are inherited by the subclass. Now there are two things that we can do here from within from the student class. The first one is that we can add its own methods, right? So we can say by, for example, we're going to say return again bye bye. I'm on my way to this dot university. University, like so. Now, of course, that this dot university is not populated yet because university is not part of the superclass and we are not doing the assignment here. So let's do the assignment. This dot university is equal to university. Once I save this, now I can actually say bye from my student object. Let's save and let's run this in the console and you'll see bye bye, I'm on my way to Harvard. Of course, if I were to create here, let me add a couple of new lines. If I were to create here const my person is equal to a new person, Jane, here then I have only access to the properties and the methods of the person class. I don't have access to the methods and the properties of the class student. So my person dot say bye is going to throw an error, right? If I save this, then it's going to throw an error because my person dot say bye is not a function. There is no say bye function or say bye method in the person class. Let's delete this buggy line of code. And the second thing that I wanted to show you here about the student class is that we can actually override the behavior of the say hi method. Let's say that we want to define another behavior for the method say hi when we are invoking it from a student object. So we can simply do it like so. We declare the method exactly as it is declared in the superclass, and here we can override the behavior. And I don't know how to write that like so. What's up, right? What's up? I am blah, blah, blah. So now if I were to say here, let's just erase a couple of things, delete to make it easier. And here I will say console.log myperson.sayhi. Okay, so I'm just gonna group things together to improve a little bit of understanding. And now we will see that the myStudent.sayhi is gonna print something different than the myperson.sayhi. Once I save this and run, oops, it's too much at the bottom, like so, you will see that we have different outputs. So this is one way that we can, for example, define a default method for a certain class, but then from the subclasses, we have the freedom of really redefining this method as we please. So we can change the behavior as we want. And this is quite a powerful feature. And of course, you will not always use them, but at least it's very useful to know that they exist. That's it for today. In the next video, we will talk about arrays. And if you don't want to miss that, make sure to subscribe to the channel and you will get a notification when the video is out. See you in the next video. Bye bye.